Hello, I'm Arthur, and today I'll present our work on characterizing task-relevant information in software artifacts. To get started, let's take a look at a software task, such as this one from Kanboard, where I need to push notifications to a user near a due date. As the developer assigned to this task, I may not actually know how to complete it. And in such case, I can search for information online, perhaps about the technologies related to the task or how to call some method and so forth. My search will lead me to a set of pertinent artifacts from different sources, some of them from GitHub, some others from Stack Overflow or API documentation. What is challenging here is that these artifacts, they may contain thousands of sentences, and only a few of them, as the ones that I'm highlighting, might actually contain text that helps me complete the task. As failing to locate these may lead to an incomplete or incorrect task, researchers have investigated ways to assist locating such relevant information, such as the work done by Sarah and Trude on Stack Overflow. Our research, it tries to take one step further of not looking at a single type of artifact, but rather several. We actually question if the text snippets within these artifacts has some commonality or some common pattern. This is actually rephrased as one of our research questions. Are there cues relating relevant text to a task? And to understand potential cues, let's take a look at 3 sentences extracted from some of these artifacts. Identifying patterns from eyesight may be challenging. So we actually look to techniques from linguistic theories, namely frame semantics. What frame semantic does is that it looks at key events in a sentence, such as the verb use in these 3 sentences, and it extracts a frame from it, in this case, the using frame. When we see such a verb, use, we always ask questions such as use what, or use what to what end. And when we do so, we look at the verb and we look for nearby text to understand it. And this is also captured by frame semantics. So in these sentences, we can see that there is an agent using an instrument for some purpose. And this is actually a pattern that we see in the first and in the third sentence. For the second one, there is still a partial match using something for a purpose. So this might suggest that indeed there is a pattern, but to answer this question, we actually conducted an empirical experiment where we had 6 tasks that required developers to forage information, 20 participants with software development background, and then we had a set of 20 artifacts curated specifically for these tasks. As you can see in the animation, participants started to highlight the text. And the more warm a text snippet is, the more participants highlighted that piece. And this is actually interesting because it's one of our first findings. Relevancy is not static, but rather it varies according to a participant background and knowledge about the task. Several sentences on the left side were highlighted by only 1 or 2 participants at most, whereas some others were highlighted by many. To understand common patterns within these sentences, we applied techniques from text summarization and we aggregated them into tiers representing text less to more relevant for completing a task. At the top tier, we observe sentences related to a system behavior, such as captured by the frame, likelihood, or causation. It's interesting because you can imagine that when I'm looking for information in the text, one of the first questions that I may ask is, um, what causes this output, or what's the likely result for this function, and so forth. So this frame captures, these frames capture this type of information. Moving forward, we observe frames such as being returned and intentionally act. The first one relates to results of some computation, such as when you say that someone will get crypt errors. And for actions, it can be either describing how to do something or how not to. And a final example, or at the final tier, we can see frames related to using something to achieve a purpose, as I have mentioned before. There are other frames and other examples available in our paper, and I encourage you to look at them for an in-depth explanation. But regardless, this analysis led to one of our key observations, which is that despite different perceptions of relevancy, there is consistency in the text perceived as crucial for completing a task. And this consistency is captured by frame semantics. Provided these initial results, we can see that there might be other applications for the technique. For example, in the analysis or detection of information types in GitHub issues. This is a work done by Arya and colleagues, and what they did was to classify the different conversational topics within a GitHub discussion. Perhaps there is a bridge between their categories and some prominent frames for each one of them. And we plan to explore that as a potential venue of future research. There are other studies that can benefit from the technique, such as patterns of knowledge in API reference documentation or development emails in intention mining by Disorbo. And future studies will look at the applicability of semantic frames in this research. So there are other findings in our paper, and we describe the aspects related to how developers read and forage information. I encourage you to look at it for more details. Thank you for your time.